space using a Venn diagram. Now, our Venn diagram we're going to be using is not classic one. You think like this, right here. It's going to look a little bit different. Okay? So, a sample space represents all things that could occur for a given event. In set theory language, this would be known as the universal set. All elements defined by that set. We often use Venn diagrams to display the relationships within sets and sample spaces. So here we have a bag, and in it we have 1, 2, 3, 4, 5, 6 white marbles, and 1, 2, 3, 4 red marbles. So this box over here, we're going to put an M here to represent marbles. And I'm just going to put the white marbles in. 1, 2, you can put them anywhere you want. 4, 5, 8, 9. And then the red marbles, let's figure out some way to, you could use color, obviously. So I did something like this. And I went 3, 5, 8, 3, 4, 5, 8. 3, 4, 5, 8. And if you don't have color, then you might need to shade in around the numbers just to designate which one's which. So even if I wasn't using red, I need to do something to designate the difference. And that represents the bag. The box represents the bag basically, and then you designate one set of colors from the other. So define and diagram outcomes. You can read this on your own. Okay? So go ahead and hit pause, read what's written there, and then we'll fill in the blank. So let's start with the sentence above the fill in the blank. The outcome could be picking a heart from a deck of cards, rolling an even number on a die, spinning a spinner and getting blue. Basically, an outcome, that's horrible even by my standings. An outcome is simply a subset of the universal set. So a subset, sub meaning under, is a collection of elements that exist within another set. So if all elements of X are in Y, then this set X is a subset of Y. All right? So, for example, if you roll a die that had 12 sides on it, the universal set is all 12 numbers, 1 through 12. But if you were trying to roll a prime number, look for a prime number, we use P for prime, and that's 2, 3, 5, 7, 11. Those are a subset, those are contained within the universal set of the numbers 1 to 12. Or an even number, less than 5, we say set E. We can say set F for representing the 5. But basically that's only 2 and 4. 6, 8, 10, and 12 are all greater than 5. So it's a small subset of the numbers 1 through 12. So here we go. Looking at this. Diagramming an outcome. So we're going to make our box. I'm going to put an M for marbles. Now, we're talking about this subset of red marbles. So I'm going to start off with that and actually make those a subset. And it's 3, 4, 5, and 8. And those are my red marbles. Represented here, 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 and here. And then my white marbles, see here's 3, 4, 5, 8 that are red. My white ones are part of the universal set. So I have a 1, a 2, a 4. You can put them anywhere you want. Get creative with it. You don't have to line them up like me. 5, 8, and 9. Those white marbles are part of the universal set. So notice this kind of horseshoe looking thing here. This is saying set R is a subset of U, the universal set. Now notice the difference compared to up here. We weren't talking about subsets, we were just talking about all of the elements of the bag that were in the universal set. Down here, since we're mentioning specifically the R's, the reds, they are a subset of the universal. Okay. Oops, I forgot something. Forgot the probability part of it. Oh, that's because it looked like it didn't print. Oh, it didn't print. This is my box that should have gone on the previous page. That's why I was missing, sorry. Okay, well, you just transfer the picture to that or just know to look back the page. So the probability of set R, which is the probability of red, R for red. Okay, so we have our reds out of our full set. Well, that's going to be 4 out of 10, or 0.4, or 40%. Remember, we can write any of those three ways: the fraction, decimal, or percentage. We have a 4 out of 10 chance of getting red, 0.4 chance, it's got to be between 0 and 1, or 40%. Now, if we define set E to be a set of all even numbers in the bag, we can determine the probability to be these right here. Some red, some white. But we're going to use set E as a subset of set U. So again, we say marbles. Okay. We're going to say set E here. I'm sorry, I forgot on the previous one. I screwed up. Forgot to label this set R for red. So set E, and then we just put in the 2, the 4, and the 8, which are white, and the 4 and the 8, which are red. And once again, you might want to color in partially to designate that this is the red set. If you want to put 8R and 4R, you can do that. Just something to designate it. So that's a subset. We have all those marbles in that subset. And then we have to have the remainders out here. The 1 white, 5 white, and 9 white. And we also have our 3 red and 5 red. And again, if you want, you can color these in. If you want to put R to designate red, that's okay. But something to designate the red from the white. And there you are. That is showing set E as a subset of the universal set. Now, what are the chances of getting that? Well, how many are in set E? 5 out of 10, or 0.5, or 50%. So you have just as good of a chance of getting an even as an odd. Again, we define set L to be all the numbers greater than 3 in the bag. Here's all the numbers greater than 3. We're going to need a little bit bigger bag. We call it set L. And we have 4, 5, 8 red. 4, 5, 8 red. And remember, we're going to do something to signify which ones are the reds. And color it in. And then we have 4, 5, 8, 9 of white. Now what's left is 1 white, 2 of white, and 3 of red. So we're going to color in somewhat. And again, that's our marbles. Now, how many are in set L? Well, there are 7 out of 10, or 0.7, or 70%. So you have a pretty good chance of getting a number greater than 3 if you just randomly reach in and pull them out. Okay. The complement of an event, which is the not. So it's kind of like when you take a test. If you got 17 out of 20 correct, you got 3 wrong. That's the complement, the not. So the complement of an event is a probability of everything but that event occurring. So if the event was set A, the complement is noted as set A with a little c. Everything that A is not. So if the probability of picking yellow is 3/11, or your score on your test was 3 out of 11, then the complement of not yellow is 8 out of 11. So an easy way to calculate the complement is the probability of the complement of A is 1 minus the probability of A. This works because all probabilities add up to or sum to 1. So the probability of A plus the probability of the complement of A adds up to 1. So first we know about set A being here. If set A is here, the rest of all of this is everything that A is not. So when determining the probability of a complement, it's usually simplest to calculate the event, then subtract from 1. So, given a bag of marbles with 3 green, 2 yellow, and 5 red. First off, always total up. 5, 6, 7, 8, 9, 10. There are 10 marbles in the bag. So, what's the probability of not getting a green marble? First, find the probability of green. 1, 2, 3 out of 10. Then, you do 1 minus 3/10, which is 7/10. Or, you can just count 1, 2, 3, 4, 5, 6, 7. Which is easy to do with small amounts, but if you have a large amount, you might want to do the 1 minus trick. So, when rolling a single die, what's the probability of not getting a 6? Well, the probability of getting a 6 is 1 out of 6. 1 minus 1/6 is 5/6. That's the probability of the complement. 1, 2, 3, 4, 5 chances. So example, when picking a card from the standard deck, what's the probability of not getting a diamond? Well, how many diamonds are there? So first off, probability of getting a diamond is 13 out of 52. 1 minus, so the probability of not getting a diamond is 1 minus 13 out of 52, which is 39 cards out of 52 cards. There are 32 non-diamond cards. That's it.